Okay, let's consider radical functions where we're taking the root of something. And we can have odd roots and even roots. And the characteristics of the odd root as far as domain and range, um, even increasing and decreasing in behavior. All of that is a little bit has different characteristics between an odd root and an even root. And we're going to look at both an odd root and an even root here in this little time together. But we're going to be analyzing the function as to domain, range, intercepts, in behavior, continuity, and where the function is increasing and decreasing. Now we have a function here which is the negative cube root of 12x squared minus 5. And I'm going to graph this on the calculator here momentarily, where we'll discuss the domain, range, in behavior, continuity, and increasing, decreasing. But as I look at this function, guided a little bit here by experience, I think the intercepts are going to be irrational numbers. And so we're going to algebraically solve for the intercepts because I don't think they'll be easily discernible in looking at the graph. Now, if I want to find the x-intercept, I set y or f of x equal to 0, and then we solve that. Let's say I'm going to do it like this. So the first thing I would want to do is divide by this negative 1. Well, 0 divided by negative 1 is 0. And then I would want to cube both sides to get rid of the cube root. And 0 cubed is 0. And after cubing the 12x squared minus 5, cubing the cube root of 12x squared minus 5 would be left with 12x squared minus 5. We add both sides, add 5 to both sides. So we got 5 equals 12x squared. Then we divide by 12, x squared, and then we take the square root of both sides to isolate the x. So we'd have the square root of 5 over the square root of 12 equals x. Now I'm not going to stop there. And before I rationalize the denominator, I think I'm going to simplify the denominator, because the square root of 12 is the same as the square root of 4 times the square root of 3. And of course, the square root of 4 is 2. So then that would give me the square root of 5 over 2 times the square root of 3. That's the same as the square root of 12. Now, mathematicians don't like radicals in the denominator, so we're going to rationalize this by multiplying the square root of 5 times the 2 over 2 square root of 3 times 2 square root of 3 over 2 square root of 3. And once we do, let's see, square root of 5 times 2 square root of 3 is 2 square root of 15. And let's see, 2 square root of 3 times 2 square root of 3. Well, 2 times 2 is 4. Square root of 3 times square root of 3 is 3. So that's going to be 12, but I can do a little simplification here. I got a 2 and a 4. Simplify that. So my x-intercept then is going to be at 15. 2 times 3 is 6. Square root of 15 over 6. Like I say, I thought it was going to be a strange number. So that's going to be my x-intercept. Square root of 15 over 6. Now, if I want to find the y-intercept, I set x equal to 0 and solve. So here we'd have y equals negative cube root of 12x squared minus 5. And let's see, well, if I set x equal to 0, 0 squared is 0, and 12 times 0 is 0. So we got y equals negative cube root of negative 5. Well, if we divide both sides by negative 1, cube root. Then we would end up with y equals, and cube both sides, we'd end up with, no, I'm not going to cube both sides. Actually, the y-intercept is going to be the cube root of 5. Cube root of 5. Another irrational number. All right, well, let's go to the calculator and let's actually graph this radical function and finish this off by looking at domain, range, intercepts, and behavior, and so forth. All right, well, here we are at the calculator. Let's graph this thing. So it was, what, negative cube root. All right, now to get to a cube root or something other than a square root, just a reminder, you probably already know this, but you hit the math button, and here at option 4, I've got a cube root, and option 5 gives me any other type of root. Now, if I'm entering that as just as an aside, if I was like doing the fourth root, which we're going to look at in a moment, I'd do 4, and then I'd enter the number 4, and then hit option 5, and it would load in the fourth root. But here I can just choose option 4. It's going to give me a cube root. So I'll do that. And we got, what was it, 12x squared minus 5. All right, clear that. Let's take a look at the graph. Now, and you can see it's got kind of a weird loop in there. Now, and actually, if you look at where that loop is, it is at the y-intercept, which we'd already determined was the square root of 5. No, cube root of 5. Cube root of 5. Now, domain. There's really not any restrictions on the domain. We're going from negative infinity to infinity. But I do have restrictions on the range. So I don't have anything above that cube root of 5. So my range is going to then be negative infinity, comma, cube root of 5, if I'm writing it in interval notation. And of course, we've determined that the x-intercepts, and I don't think I did it over there, but we should have done plus or minus square root of 15 over 6, because remember we were taking the square root. We got a y-intercept at the cube root of 5. Now, what about our end behavior? See, on my left end behavior, as x is approaching negative infinity, well, then f of x is equal to negative infinity. But also on my right end behavior, as x is approaching positive infinity, well, f of x is still going towards negative infinity, so f of x is negative infinity. We're going to be continuous. I can actually draw this without lifting a pencil. We're going to be continuous for all real numbers. And then we're going to be increasing until we get to where x is equal to 0, right here. And so we're going from increasing from negative infinity to 0. And then we are decreasing from 0 to infinity. All right, well, we're going to do one more. I'm not going to graph that on the screen. I've already done a screenshot of the graph of something that had to do with the fourth root. All right, well, here we got a fourth root. We've got 1/2 times the fourth root of 2x cubed minus 16. And it's got all the characteristics of an even root. In fact, it even looks like a square root, if you will, but that's why it's characteristic of an even root. Now, on the domain, well, you can see that we go from 2 right here out to infinity. Our range is also from, well, not also, our range is at 0 to infinity. So let's see, domain, change color on this. So our domain then is equal to, and includes 2 to infinity. Our range includes 0 out to infinity. We do not have a y-intercept, but we do have an x-intercept at 2. And let's see, on our limit, on our end behavior, I only got right end behavior, so we would say that we've got a limit as x approaches infinity, f of x is equal to infinity. We are continuous from 2 out to infinity. And then we could also say that we are increasing from 2 out to infinity. All right, radical functions, analyze, domain, range, intercepts, end behavior, continuity, and increasing and decreasing. Never had so much fun in my life.